We're going to have Sarah say something about diabetes. There was a question. So now we have to focus. This is how we focus. The hallways for talking, right? No one's chained to their seat. Are you chained to your seat? No. Not to your knowledge. Good answer. Sarah.
So in class yesterday we had a question about diabetes mellitus, and so from the exam there's a question about what caused it, and so the answer was that the pancreas secretes too little insulin, and the confusion came because one of the students was wondering if diabetes mellitus was type 2 diabetes, which it can be either. It's a more general term. So it's not going to be specific to one or the other, and you wouldn't distinguish between type 1 and type 2 in that instance. And then you could figure that out in the exam in the test, because there was no other
I was going to say,
answer that would have
if I remember right, I didn't put the other alternative in.
Yep, there was no other alternative except like the pancreas secretes too much insulin, which would not prevent the appropriate answer for type 1 or type 2. And the other ones were like 50 normal. So.
Yeah, I think that's probably the right way to explain that, because I think when I put down the 6 answers, I knew that one answer could be confusing. If I had the other one, maybe there were 2 right answers. So I think that's what I left out. And then I did look up a general definition here, and it is a little confusing, but see, this one says, I looked up diabetes mellitus, and it says a disease in which the body's ability to produce or respond to the hormone is impaired. And that's kind of what we're talking about. And then there's elevated levels of glucose in the blood and urine usually. So it's a little confusing, but I think on that question, because when I started grading it, some people were getting it wrong, and I go, did I do something wrong as far as the other choices? So yeah, good discussion. Always, that's what's important. Okay, so without further ado, I'll start out. Instead of me going to my stuff right now, I always see if the audience has any questions. Anything? Because we're doing gastroenterology this week. Anything that's on the videos or fuzzy? Did the videos talk about atresia ani? Okay. Did I say in the video that I ran into a calf with it? Do you remember that? Is that, maybe I didn't.
In the video, I had it.
Did it?
I had it.
Yeah, because it was one morning, like early, and we were calving out. This is at the one of the Purdue farms. We were calving, and I got a lot of great experiences, but we were calving out some beef cattle, and then there's this calf standing over in the corner. I'll never forget it. Kind of away from mom, and his stomach was tucked up. And of course, when if you know your animals' behavior is how they signal to you something's wrong, right? So this calf didn't look well, but he had been born a couple days ago, and I think I had seen him nursing, so it's like, okay, what's going on? So the first thing you think about with young animals is diarrhea, because a lot of times animals die of dehydration due to diarrhea, okay? So, diarrhea leads to dehydration because the large intestine is supposed to absorb a lot of the water in the fecal material back into the body, right? And diarrhea is things are passing too fast and you're getting rid of a lot of water. So if you're looking for a calf, it was a male calf, boy calf. So his penis is down, on his tummy side there. So anyway, so I lift up the guy's tail, looking for diarrhea. And then I put it back down and I go, it's kind of early, but I don't think I saw an anal opening. All I saw was hair. Lift it up again, and lo and behold, there was no anal opening at all. So he had been living for 2 days without defecating. No wonder he was having probably a tummy ache or whatever, not feeling well. So I put it down, and it was a Saturday morning. I had a Purdue pickup, but the pickup didn't have a stock rack on it. And he was only 2 days old, so he wasn't that old. So I had him ride shotgun down to the vet school. So I knew he wasn't going to defecate, right? He might have urinated in the cab, but so here we are. He's riding shotgun. I'm driving a Purdue pickup, and Dr. Baker was down. It was a Saturday. I'm pretty sure it was Saturday or Sunday. Dr. Baker was manning the large animal clinic I happen to know him, and I had to go back to do my chores, so I dropped off the calf, and then I found out later that they were able. So what happens when you have atresia ani, and it's also called anal atresia, it's in both terminologies apply. They would have had to euthanize the calf if they would have made an opening where the anal opening was supposed to be, and if they couldn't find the rectum close by. You know, if it was that far away, they probably never would have been able to get it to sewed and replaced. But it's actually just right below where it should have been, right below the surface. So they did a, you know, artificial anal opening. And I think they sold the calf because, you know, we didn't have time to take care of it like it should have. But I don't know his eventual demise or whatever, his future, but at least he was saved anyway. So that was very interesting. It happens in pigs. Anybody here ever run into animals, newborn animals? What did you have back here, way back?
A pig.
A pig?
A puppy.
A puppy, okay. In those cases, were they euthanized? Do you guys know? The puppy wasn't?
Yeah.
Okay, tell me what happened to the puppy.
Well, I just saw it after. I worked at the veterinary specialty center over the summer.
Yep.
So I just saw it after the operation, so it was successful.
And so it was successful. So it must, the large intestine, I think during fetal development, you know, it finds the back of the animal, and then there's an anal opening made, right, during the embryonic stage. So it must have been pretty close that they were able to sew it. Yeah. Probably doesn't work like a normal sphincter, right, but probably doable. But the pig was euthanized, right,
Yeah.
back there? Yeah, because it's just...
Yeah, it was commercial settings.
Yeah. Anybody else? Did anybody else have an experience of the atresia ani? So we have a dog, pig, and cow example. Okay. Okay. Anything else? Well, here, what I'm going to do now is, I think what I did last week helped a little bit. I'm going to go to the reading. Because I think early in the semester people weren't doing the reading because you can kind of tell that with the answers that were picked that weren't the right answer. So let me do that, and we'll just see if there's any questions as I go along. You know, we're down here, and it's called gastroenterology. It could also be called digestive physiology. You know, we're going to talk about the GI tract from one end to the other. And I think in one of the videos I talk about how, and this is a neat concept, the digestive tract could be considered a tube within a tube. Did I say that in the video? Anybody remember that? Okay, so what it is think of a tube, just like a pipe, and that's the digestive tract. The lumen has the food, and sooner or later the nutrients get absorbed. But then there's another tube around that, and that's the human body or the animal body. Maybe what I can do is draw that, because it is kind of a neat concept. Let me get a piece of paper. This is good enough right here. So the digestive tract is a tube within a tube. So if there's something in the lumen of the digestive tract and it's poisonous or harmful, if you can keep it in the tube, it won't harm the body. It's an interesting concept. Like if it's a bad chemical, and if it would get into the blood, it might damage an organ. But if you can keep it in the lumen, then it'll pass through and won't poison the other tube. So let me do that, because it's an important concept. Okay, document cam. Warming up. Here we go. So here's the body. Think of the body as the tube. So this is skin. What's another name for skin? The integument, okay? So then, you have this tube, which is the GI tract. GIT, gastrointestinal tract. And if there's a poison, let's make X a poison, and you can keep it there and not let it get here, then it will pass out the other end, right? The anal opening, and not affect the animal. Does anybody have an example of how you can do that with certain poisons? You can give an animal something, and it'll keep the poison in the lumen, and off it passes. Activated charcoal. Yes. So it's a great example. I'm going to Google it because so you can see it.
You switched the hand.
Okay, good. Keep me on track. Keep me on track. Here we go. Activated charcoal. Did they do it? Yeah. Okay. Now what's kind of interesting is it's charcoal and it's very fine. So what's interesting about activated charcoal is that chemicals like to adhere to it and not let go. So let's say an activated charcoal is, imagine a cube, like a box. And you know how a box would have a very flat side, so there wouldn't be much surface area? But activated charcoal is like that box, but with dozens of little indentations where chemicals can adhere and not be released. So it's very, I'll say it's porous. I'm not sure if that's the right word, but this activated charcoal is very porous, and chemicals tend to, and it's like, let's say all chemicals, it's not like selective chemicals. So activated charcoal is not selective, but chemicals like to adhere to these molecules of charcoal, and then they're carried out with the fecal material. So it's very common. In fact, last fall in this class, one of the girls had a bearded dragon. And lo and behold, she carried activated charcoal with her. Because if it happened to eat like an insect or something, like something off the floor, or I guess fireflies are very poisonous to bearded dragons. I've learned that. But if you saw, let's say, the bearded dragon eat a firefly, then you would give it this activated charcoal, and hopefully the chemical that would kill the animal would be kept in the digestive tract by the activated charcoal and pass out the other end. So, I mean, I think you can buy it at Walmart. Anybody, do you use activated charcoal for anything? What did you use it for? Or
Oh, I use it to usually
so for in the human sense, right? Yeah. So you can, yeah, it's just like it absorbs things and it doesn't let it go. Okay? So activated charcoal. So the tube within a tube is a great concept. Let's get back to reading now. So gastroenterology, whenever you see entero, that means intestine. So gastro is always stomach, entero is always intestine, and so that word literally means the study of the stomach and the intestines, and that's pretty much the digestive tract, right? There's the esophagus too, but that's pretty much it. So let's go to the first click, and got to remember, this is not a nutrition class, so I'm not going to say the classes of nutrients this, what does vitamin A and B do, but you guys have had some of that in the back. What's the fat-soluble vitamins? A, D, E, K, right? And then the water-soluble are everything else, basically C and the B complex. Okay, so you got these little reading material here. The gut and digestion. So this is another thing too. Sometimes the gut, people use that too loosely, because usually when you say gut, a lot of times my mind goes to the intestinal tract, but I think sometimes they include the stomach in that. And then of course there's classes of nutrients. I mean, like cattle, for example, are herbivores. It's kind of interesting. You know, cattle are ruminants and deer are ruminants, right? But they're not equal, because you can be a very poor ruminant, you can be a so-so ruminant, or you can be a very fantastic ruminant, right? If you have a rumen. And so like a deer is not the best ruminant, but they are classified. But probably the best, one of the best ruminants is probably a dairy cow. All the stuff that's going on in that rumen, and then they're making like 100 pounds of milk a day. So it's very functional. So then, of course, carnivores, like those in the dog and cat family, this is always kind of controversial, but dogs are not true carnivores. Now wolves, you know, are carnivores, but they're not actually true carnivores either, because they can have some plant material. But a cat is a true carnivore, and it's called an obligate carnivore. O-B-L-I-G-A-T-E, right? Obligate carnivore. Does anybody know why it has to be, why it's called an obligate carnivore? The cat?
Keratin.
That's one of the reasons. Okay, they can't take keratin from plants and make vitamin A. And vitamin A does not exist out in the plant world. So that's one reason why cats have to have animal sources. They must have it in their diet. A dog, you could feed it like a vegetarian, unfortunately, but that wouldn't be the best. But cats are obligate carnivores, and there's other reasons. Like sometimes you'll see like 6 reasons why cats are obligate carnivores. Okay, and the keratin to the vitamin A is definitely one. And then they also need taurine, Taurine, the amino acid taurine, and that has to be coming from an animal source. So cats are obligate carnivores. They have no choice. Dogs are basically a carnivore, but they're not an obligate carnivore. And then of course when you talk about, let's say, amino acids, and I'm doing a little intro here, sometimes there's things called essential amino acids and then non-essential amino acids. So I want to focus on what does essential mean and what does non-essential mean. Anybody get that from the nutrition class?
Essential, you have to take it from a different source, like feed or something, because your body doesn't create it. Whereas non-essential, your body will create.
Okay, yeah. Essential means must be in the diet. Non-essential means somebody in the body can maybe make it if it's short. And what's the default organ you guess that makes those non-essential amino acids? Liver. Remember, that's a big default organ. Okay, so read this, omnivores. Of course, omni means all. That's a prefix meaning all. So then omnivores can do both. And then there's all kinds of, treatments of food. Okay, so here's the deal. This is a good diagram because it kind of puts the tube within a tube. Isn't that how they do that? Probably better than mine, because this is a side view. So this is the digestive tract, and it's a tube within a tube. And you have these large macromolecules. When you eat, an animal eats, all those molecules are called macromolecules. They're very complex. And if you left them in that form, they would all pass out in the fecal material. You can't absorb macromolecules. So the whole function of the digestive tract is taking these large molecules and making monomers. M-O-N-O-M-E-R-S, monomers. Monomers are like one unit of something. Like you can eat carbohydrates, that's the macromolecule, but the monomer is glucose. You absorb glucose. So this whole digestive tract is functioning there. And of course, this is basically the mouth and the esophagus. And what's the accessory digestive organ that's not displayed in this diagram? And so on the little sidebar, hopefully you know there's 3 what's called accessory digestive organs. You could, for this diagram, if you wanted to modify it, you put like a little duct that leads to the mouth and make a gland here to symbolize the first accessory digestive organ of the digestive tract. What is it? Salivary glands, okay? And they have an exocrine function. Remember that term from weeks ago? Exocrine means something passes to a duct to a free surface, okay? And this is called a free surface. There's nothing beyond it. So salivary glands add material to the digestive tract, lubricant, for example, and in cattle, what's the important job of saliva?
Buffer.
That's a buffer. It's got to have a lot of buffering ability because then the cow makes, the number of liters of saliva that a cow makes is stunning. And it's like many, many liters. I can't remember the number right now. But there's a lot of buffer in there because the rumen, whenever you have metabolism metabolic processes always generate acid. So the rumen wants to go low pH. Does that make sense to you? Acid is low pH. So then that would be bad. So then the saliva counteracts the acid production by the microbes and brings it closer to neutrality. Okay? So you got saliva, and there's more than one salivary gland, but we won't get into the paired and the single. If an animal, what's like for a dog, what's something that can come out of the salivary glands that are bad? I'm being very elusive, but sometimes if you get bit by a strange dog, and then what happens? What might be you're afraid of?
Rabies.
Rabies. Rabies is let loose in the saliva. And it's a crazy thing because rabies, whenever an animal gets bit, the rabies virus travels on nerves to the brain. And then the virus replicates in the brain, and then it follows the nerve that controls the salivary glands, and the virus, the active virus, is in the saliva of an animal. So if you ever get bit by an animal, especially a dog or a cat, you got, is it vaccinated? And then a lot of times they watch it. But you can get rabies from a cow. Veterinarians have gotten rabies from a cow. It might act like it's choking and you're back in there trying to see if there's any obstruction, and those teeth in all those animals are very sharp. Most veterinarians are vaccinated for rabies, so it's not usually a problem. Yeah?
I've heard, like, depending on where you get bit, like it's your hand or like your neck, it's like much worse to get bit in your neck because it can get your. Do you believe that? Like, is that true?
Oh yeah,
Oh yeah. Does it really make that big of a difference?
I think so, because it travels on nerves to the brain. So like, you don't have a choice where you get bit, but if you do have a choice, get bit in the foot rather than in your arm.
So you think it really does take that longer?
Yeah, I think so. I've heard that too.
Can all animals get rabies?
Yes, yeah. It is amazing. I mean, all mammals. And then when I was in school, they didn't think bats transmitted rabies, but yeah, you can get rabies from bats. Every animal can get rabies, every mammal. But it always goes to the brain, and then it follows the nerve tract to the salivary glands. And that's why it's so bad to get bitten, because there's always saliva in the mouth of an animal, right? Yeah. Okay, good question. So then we have that must depict the stomach, but you can see the large molecules are getting smaller and smaller. And then here, in the small intestine, is the major site of absorption. And notice how it says absorption. This must be the English spelling, because that's not how we spell absorption. But it's probably the English version. But notice how then the body cells uses those micro molecules or those monomers. So the small intestine is a major site of absorption. Okay, and then so let's say if this is glucose. Then if you remember when we did kidneys, I said I like to have, when the glucose gets out of the crude urine back into the blood, I like the term reabsorption, right? So you have absorption of glucose here, but you have a reabsorption of glucose in the kidney. And then whatever comes out here in the large intestine, you get absorption of a lot of the material, the water, I should say, and then you get fecal material. So that's a tube within a tube, of course. Ruminants have 4 compartments in their digestive tract that act as 4 stomachs. Sometimes it's said. There's that reticulum, rumen, omasum, and abomasum. And what's the true stomach? What's the organ of those that are like the true stomach? The abomasum. It's the last one. Okay. And then you have, so then cattle and ruminants can be called foregut fermenters. And that's where you see gut means intestine. So if you're a foregut, that's F-O-R-E hyphen gut. If you're a foregut fermenter, you're fermenting feedstuffs before the small intestine. Okay? and that's like a ruminant. How about hind gut fermenters? So you have foregut fermenters, you have hindgut fermenters. I told you some of the foregut fermenters. You tell me some of the hindgut fermenters. Horses. What else? Rabbits. Did somebody say llamas? I thought llamas were.
Could be wrong.
Aren't llamas ruminants?
I thought they were. I'm probably wrong.
Okay. I think.
Yeah, I'll just look it up.
Yeah, we can all look it up. I think llamas are ruminants.
I
Are
think
they?
they are too, because doesn't one of them, like llamas or alpacas, doesn't one of them only have like 3 compartments?
They're
I-
pseudo-ruminants.
What's that?
They're pseudo-ruminants.
Oh,
They have
pseudo
three-chambered
ruminants. Oh my
stomachs.
gosh. Okay.
3-chambered stomachs because they're missing the omasum.
Are they really?
Yeah.
Okay. Okay, that's interesting. See, look at how much we're learning. So llamas and alpacas are pseudo-ruminants because they're missing the omasum. Okay. That could be a good quiz question. Yeah, because we're working on it. Okay, so the hindgut fermenter. Horses, rabbits, pigs. And you might say, what? All the pigs I've ever seen are raised with like soybean meal and corn ground up. Do you know pigs can live on pasture? Or just ask any wild pig in Arkansas. Right? They're out there foraging. And if you took 2 identical pigs, listen to this, and fed one like in a confinement of soybean and grain, but let the other pig live all in the pasture, do you know if you dissected those 2 animals, I could tell you which one had lived on a pasture and which one had lived inside a building fed grain if I just looked at the digestive tract? Because the animal that lived outside that had a lot of forage, its cecum would be bigger, even if they were identical pigs. Because the digestive tract is very dynamic. If it's digesting a lot of forage, like the pig out on the pasture, then the cecum would be larger. It would accommodate all that forage. Whereas the pig inside fed cornmeal and soybean, its cecum now, remember, would be smaller, definitely. Because cecum really is where the hindgut is fermenting, right? And horses have a problem because they're almost too big back there. Horses have incredible large cecum and large intestine, and sometimes you have trouble. And horses, there was probably one following me this morning when I went by the vet school. What's the general term when your tummy hurts, your digestive tract hurts? Colic, C-O-L-I-C. Colic means abdominal pain. That's all it means. Colic, abdominal pain. Yes?
What were the other 2 accessory digestive?
Yeah, we're getting to those. Good. Her question was, what are the other 2 accessory digestive organs? Because hopefully in the sidebar you said 3 accessory digestive organs, salivary glands, and then 2 and 3 are blank right now. Okay, so before with this ends, we will get there. Okay, so anyway, that's easy reading, blah, blah, blah. Now this is British, because here's the point. Look at how they spell esophagus. So whenever you see the O in front of something that starts with E, and you know it's, for us, it'd be E, that's the British way to do it. And it's really weird because, you know, cows can be an estrus, E-S-T-R-U-S, right? The British spell it O-E-S-T-R-U-S. But it's still good material. Anyway, we're going to do the other 2 accessory digestive organs. So, the 3 accessory digestive organs are all exocrine glands. That means something comes out of a duct and goes to some free surface. Okay? And so the second one I want to talk about is this one right here, the pancreas. Notice they've even drawn a duct to the GI tract. And it's very close to the stomach, to the pyloric sphincter there. So the pancreas is the second accessory digestive organ. It has an exocrine function, and that's pancreatic juice. So it's a juice material that flows into the small intestine And the two main ingredients in pancreatic juice are what? Enzymes and buffers. Because the contents of the stomach are incredibly acidic, right? 1, 2, or 3 pH. So you have this very acidic material coming out into the small intestine, and you better neutralize it now, not later. Now you know then the pancreas has endocrine functions too, right? Remember we just talked about insulin. So be aware that some glands have part of it is exocrine and part of it is endocrine, and the pancreas is a great example of that. In fact, you could go, nobody goes to the library anymore, but if you went to the library, in some shelves, you could find a book that's called The Exocrine Pancreas. And it would just talk about what the exocrine function of the pancreas is. And then maybe right beside it, there'd be a book called The Endocrine Pancreas. Because they're very two separate functions. Okay, then the third accessory digestive organ, I'm pointing to it, the liver. So what does the liver put into a tube that goes down to the GI tract? Bile. So bile is going in a duct. There's a gallbladder. So this would not be a horse, right? This could be a dog, let's say. And there's bile. It stores, or gallbladder, it stores bile. But if an animal doesn't have a gallbladder, it's still making bile, but it's just being put into the GI tract as it's being made. And there's the duct, the bile duct. Sometimes they share a common tube in the terminal part of their two ducts. So that's the three, Audrey, the three accessory digestive organs. Okay, so then they're all listed there, liver, pancreas, mouth. Yeah, there's the salivary glands, okay. Teeth, all kinds of teeth. A dental formula. Okay. Let's remember the dental formula for the sheep, and that's right there. So let me explain it a little bit. Dental formula, and we'll do the dog too. We'll remember the dog and the sheep, okay? So what happens is you have an upper set of numbers and a lower set of numbers. And there's got to be 4 numbers in each line. So the first number, I'll do the dog first. The first number is how many incisors on 1/2 of the upper arcade. Okay? So you got 3, and then the next number is the canine teeth. And then you have premolars, and then you have molars. Okay? So now you know the upper arcade, there's 2 canine teeth in the upper jaw, right? But this only says 1 because we're starting on the midline going around one side. So 3 incisors, 1 canine, 4 premolars, and 2 molars. So then you've got to double that to tell how many teeth are in the upper jaw. And then the lower jaw, on 1/2 of it is 3 canines, 3 incisors, 1 canine, 4 premolars, and then 3 molars. So then, to get the total number of teeth, you would add all these numbers up times 2. And what does that come out with the dog? Does it say the total number? Is it 42? Somebody add that up for me fast and double it. Anybody can do the mental math? It's either 42 or 44.
42.
42? Yeah. So remember, dogs have 42 teeth. The Great Dane has 42 teeth, and the Chihuahua has 42 teeth. Because all dogs have the same number of molars, right? They're not any different. So then let's go up to the sheep. 0033. If you ever get a chance, and this is the same with cattle, they don't have any upper incisors. And we should maybe show that tomorrow. It's like if you lift up the lip of a cow, there's no teeth, no incisors. There's what's called a dental pad, P-A-D. No upper incisors. So you got 0033, and then at the bottom there are incisors, so then there's 3133. So the total number of teeth in a sheep would be adding all those up 16 times 2, 32. So sheep have 32 teeth, dogs have 42. That's the dental formula. And it's always done that way. And then of course, yeah, there's the showing the thing. Okay, and then here they're making a big point about peristalsis, right? The GI tract is very much controlled by peristalsis. Okay, I think we'll stop right there. Good little diagrams. Don't forget about the bird. If it's in the reading, it could be on the assessment. Oh, okay, okay. Oh, was he? Okay. That's interesting. Yeah.